All right, good morning, everybody. So now today we want to look at the cases of momentum. Okay, case of momentum. So the first case of momentum is when two particles are traveling in the same direction. Okay, and they are moving with a different velocity, v1 and v2. Okay, so now these are two balls moving, right, in the same direction. Right, the first ball is moving, the second ball is moving. So this is actually before collision. Now, after these two balls collides, all right, what are you going to be having? Now, you're going to be having the two balls stick together. Of course, you should know that, all right, in collision, we have two types of collision. There's what we call elastic collision, and there's what we call inelastic collision. So now this is your what after collision. So it's going to be moving with what a common velocity because the object will stick together, all right, at this point. So if that is the case, I'm going to be deriving three values for it. For this, I will derive the value of the common velocity. I'll derive the value for the kinetic energy before collision and after collision, and the lost energy. Right, so that's what we're going to do. So the first one, so let's find the momentum. This is what mv, so we have m1 v1 here. So this is what m1 v1 plus this m2 and v2 plus m2 v2, all right, is equal to after collision. What do we have? This is what m1 v, then plus what? Plus m2 v. This is the first thing you're going to be having, right? So if that is the case now, from this place now, I have m1 v1 plus m2 v2 is equal to v is common to the both. That is v into m1 plus what? Plus m2. So that means the common velocity, all right, when two particles are moving or traveling in the same direction, all right, is gotten by making what? The value of v here, the set of the formula, which is now m1 v1 plus what? m2 v2 is equal to v, open bracket, what? m1 plus m2, then over what? m1 plus what? m2, then here over what? m1 plus what? Plus m2. So this go with this. All right, so what is left? The value of the what? Of the velocity is going to give us what? This m1, okay, v1 plus m2 v2 over what? Over m1 plus what? m2 is equal to what? Is equal to v, or the value of v is equal to what? m1 v1 plus what? m2 v2 divided by what? m1 plus what? m2. So quite cool. So if you are asked to determine the value of the common velocity when two particles are moving in the same direction, that is the formula, all right, you can use to determine it. All right, this is what we call common velocity. Okay, it means that the mass of the first ball multiplied by the velocity of the first ball, all right, plus the mass of the second ball multiplied by the velocity of the second ball, all right, divided by the addition of the masses will give us what we call what? A common what? A common velocity. So that is how to determine it. That's the first one. Then number two, we are going to move to what we call the kinetic energy before and after collision. So if you have to find the kinetic energy before and after collision, it's very simple. So let me arrange this again. So if I'm finding kinetic energy, first of all, kinetic energy is energy in motion. All right, so I have kinetic energy. Okay, now the general formula is what? 1 over 2 m what? mv squared. All right, it means that anyway, these are what the before collision is. These the values we got from before collision, and this was the value after collision. This one can be as well substituted as what? V into what? m1 plus what? Plus m2, all the same. So you can write as m1v plus m2v, or what? V into m1 plus what? Plus m2. So to find the kinetic energy before collision, one did the value of kinetic energy. So anywhere we see this mass here, so we have 1 over 2 in the formula of kinetic energy for. So I have what? Kinetic energy before collision is equal to, I have 1 over 2, m comes first, but before collision we have what? m1. So we have v1 here, this v, all right, v1, but the value of v is carrying square, so we have square plus the same thing, 1 over 2 comes first, we have 1 over 2, this m2, then v is carrying square, so we have what? v2 what? v2 square. To show that what? Kinetic energy before collision when two particles or two bodies are traveling in the same direction to become what? 1 over 2 is common to the both sides, open bracket, what? m1 v1 square, then plus what? m2 and what? And v2 what? v2 square. So this is the what? Value of ke before collision. Quite cool. So now we also go for what? Ke after collision. Okay, so for ke after collision, we have kinetic energy after collision. So for after collision, our value has become this. All right, we have 1 over 2m. Okay, because this v into m1 plus m2, it is also the same thing as what? As m1, all right, plus what? m2 Okay, everything into what? Everything into V. So once M comes up, we can say we have what? M1 plus what? M2, then all into what? V. But 1 over 2 comes first, all right? In the formula of kinetic energy, this 1 over 2, M1 plus M2. But V is carrying square. You know you have V here. Then you have what? V square. Or we can have what? Kinetic energy, all right, after collision is equal to what? 1 over 2, all right, V square, open bracket, what? M1 plus what? Plus M2. So this is the formula to use, all right, if you want to determine the what? Kinetic energy before collision, all right, when two bodies are moving in the same direction. And this is the formula to use to determine the kinetic energy after collision when two bodies are moving in the what? In the same direction. So the last one, all right, is actually, or some last is the last one is called the loss energy or the energy loss. So the loss energy in this, okay, loss energy is the difference between the kinetic energy before collision and after collision. You have to take note of that. So we have what? Loss energy, all right, is equal to kinetic energy before collision minus kinetic energy what? After collision. So that means loss energy or energy loss, all right, is going to give us our formula for K before collision was 1 over 2. You know, we had 1 over 2 M1 V1 square, all right, then plus what? Plus 1 over 2 M2 and what? V2 square, then minus, you know, our after collision just now was 1 over 2, all right, V square, open bracket, what? M1 minus what? Okay, plus what? Plus M2. This is what we had. So that means if V is 1 over 2 is outside, that is what? Loss energy is equal to this 1 over 2, all right, into this is M1 V1 square plus what? M2 V2 square, all right, then everything minus this is the final formula of what? Of loss energy. Everything minus what? Minus 1 over 2 V square into what? M1 plus what? Plus M2. So this is the formula for what? For the loss energy, all right, when two what? When two particles or two bodies are moving in the what? In the same direction. So quite cool. So this is how to go about it. It's quite simple. Thanks for watching. Do well to like, share, and comment on the video. And God bless you. Of course, you should know that elastic collision, all right, is a collision whereby momentum and energy are conserved. While the other one, all right, energy is conserved. Momentum is conserved, but energy is not what? It's not conserved. So that is how to go about that. God bless you. Bye.